All right, guys, week 11. So we're inching our way closer to the end of the semester. This week, we're looking at just 2 lessons, so one each day. We're starting with lesson 106 and then 107 we'll finish up with. So lesson 106, we're dealing with two-step equations. So again, we'll get down the road where you guys are doing 10, 20 different steps. But right now, it's going to be 2. So we're thinking inverse operations, and we're trying to isolate an unknown. We're trying to figure out what our variable is. Again, show your work. This is something, some of these simple ones you might be able to, step 1, step 2, okay, I got it. Or, guess and check, so to speak, by plugging a number in for n or x or whatever it is. But best practice is to show your work so that way you can always retrace your steps, so to speak, but also as we get down the road where you're combining like terms and you're doing 10 different steps to isolate the variable, you can keep track of it. So just take my word for it, it'd be better. So this one we have 3n minus 1 equals 20. Okay, so we want to know what n equals. Like I said, we can, what if it's 3? No. What if it's 4? What if it's 5? We can do that. For some of them, you may be able to see it if it's like 2x equals 4. Well, I know 2 times 4, or sorry, 2 times 2 equals 4. Yeah, you might be able to do that. But again, that's not going to be sound practice, especially down the road as they get more complicated. So we want to do inverse operations to get this by itself. We want to figure out what that is. So I have 3 times n minus 1 equals 20. This minus 1 I want to get rid of, so I can add 1. If I do it to the left side, I have to do it to the right side. I have 3n minus now 0, which is just 3n, equals 20 plus 1, so 21. Coefficient next to a variable, we have multiplication. We don't draw in the multiplication symbol, but we know it is multiplication. 3 times this number equals 21. So then inverse of multiplication is division. 3 divided by 3 is just 1, so 1n or n is what we want. If I divide the left side by 3, I have to do the same thing to the right side. So I can never just do it here and leave this alone. Okay, I have to do it to both sides. 21 minus 3 is 7. And the nice thing about these, I always suggest, even in my upper grades, especially if it's a test, go back, plug it in, make sure it works out to be true. 7n for n, 3 times 7 is 21, minus 1 is 20, 20 equals 20, so we know we did it correctly. So if you ever get an answer and you're like, I'm not sure if it's right, maybe I missed a step, well, plug it back in and see if it works out to be true. Okay, this is what we just talked about, inverse operations. So versus the guess and check, we actually added 1 and divided by 3 to solve for it. And so the different mathematical properties and rules are right there for you to see. Given an equation, and the inverse of subtraction is addition, the inverse of multiplication is division, and so on. And we'll get down the road with like square roots, we'll take the square and different things like that. So just think inverse operations to try and isolate your unknown. Okay, so all of these ones today are 2 steps. So we're adding, so we subtract. And we're multiplying, so we divide. And we're subtracting, so we add. And we multiply, so we divide. So the inverse of addition is subtraction, and vice versa. Multiplication, inverse is division, and vice versa. So that's inverse operations and isolating our variable. Okay, practice that we'll do together. Okay. Lesson 107, we're looking at area of complex shapes. So again, maybe it's a polygon or a semicircle or something where it's a different shape, but we can break it into several different polygons or shapes that we're used to working with. and find the area of them individually and then add them together. So if we have this one right here, we have 1, 2, 3, 4, 5, 6 sides, but we can break it into a shape. So, so let's attempt to draw these. I know this isn't drawn to scales. So imagine that as an trying my best to draw what is in the book. So we have B, A, 3 centimeters, 6, 7, and 4. So again, in these, it'll usually say, but even if it doesn't, or have it indicated with the little right angle symbol, hey, imagine all of these corners are square. If they weren't, then there's still a way we can go about finding it, but it's going to be way more complicated than what we're looking at. So all of these are right angles. So what that tells us is this side plus this side have to add up to 6. This side plus this side have to add up to 7. So we could do this a few different ways. We could fill it in and make it a rectangle and then find the area of this section and subtract it from it. That's one way. We could draw a line across here and make this a rectangle, and this one down here we could draw a line like we had right there, and look at this rectangle and this one. Again, a few different ways to go about doing it. As long as the math is correct and we do everything correctly, we should all come up with the same answer. First thing we need to know is we need to know this distance. We said 4 plus A has to add up to 6. So I know that A has to be equal to 2. Same thing here. 3 plus B has to add up to 7 because these opposite sides are parallel, and this distance plus this distance has to equal this one in order for all these angles to be 90 degrees. So 3 plus 4 equals 7. All right, now we have all of those. It's just a matter of picking what we want to do. Let's just draw a line across here. So we're looking at this 2 by 3 rectangle. So 2 times 3 is 6. And now we have this 4 by 7 rectangle right here, which is 28 square centimeters. Then we just add them together. 6 plus 28, 34, and it was square centimeters. Where do we find the area of those? Again, they, in the book, let's see how they did it. Okay, so they drew it across here. They did like we did, this rectangle and then this one. Hey, let's say, oh, I didn't do it that way. Oh, no, it's okay. You're still going to get the same thing. We drew a line down here. We got a 4 by 4 square. So this side was 4. We filled that in. This side is 4, so that gave us 16. This was 3 times 6, which was 18 square centimeters. We add those together, and we still obviously get 34 square centimeters. Okay, so just break it into shapes that you know to work with. Like trapezoid, there is an area formula for a trapezoid. We haven't gone over it yet, so you can look it up and use that. And you break it into a triangle and a rectangle. Right? That's fine. This one you can break it up here. Here you can even break it up into 3 shapes if you wanted, and then add all 3. It's really up to you as long as you're finding the area of the section correctly and then adding them all at the end correctly, and you're going to get to the same answer no matter which way you do it. All right, then 108 we'll get to next week. That is it for this week. Just those 2 lessons. So make sure you guys have this video watched, and then we'll go over more of it in class, and we'll see you then.